Python consistent hash replacement. As noted by many, Python's hash is not consistent anymore, as of version 3.3, as a random Python hash seed is now used by default to address security concerns, as explained in this excellent answer. However, I have noticed that the hash of some objects are still consistent, as of Python 3.7 anyway, that includes int, float, tuple, x, frozen set, x, as long as x yields consistent hash. For example, is that always true and guaranteed? If so, is that expected to stay that way? Is the Python hash seed only applied to salt the hash of strings and byte arrays? Why am I asking? I have a system that relies on hashing to remember whether or not we have seen a given dict, in any order, key column tuple, ints. In that system, the keys are a collection of file names and the tuples a subset of os.stat_result, e.g., size, and time, associated with them. This system is used to make update/sync decisions based on detecting differences. In my application, I have on the order of 100k such dicts, and each can represent several thousands of files and their state, so the compactness of the cache is important. I can tolerate the small false positive rate, 10 to the power of -19 for 64-bit hashes, coming from possible hash collisions. See also birthday paradox. One compact representation is the following for each such dict, FSD. It is very fast and yields a single int to represent an entire dict, with order invariance. If anything in the FSD dict changes, with high probability the hash will be different. Unfortunately, hash is only consistent within a single Python instance, rendering it useless for hosts to compare their respective hashes. Persisting the full cache, location_name column FSD_hash, to disk to be reloaded on restart is also useless. I cannot expect the larger system that uses that module to have been invoked with Python hash seed equals 0, and, to my knowledge, there is no way to change this once the Python instance has started. Things I have tried. I may use hashlib.sha1 or similar to calculate consistent hashes. This is slower and I can't directly use the frozen set trick. I have to iterate through the dict in a consistent order, e.g. by sorting on keys, slow, while updating the hasher. In my tests on real data, I see over 50x slowdown. I could try applying an order invariant hashing algorithm on consistent hashes obtained for each item, also slow, as starting a fresh hasher for each item is time consuming. I can try transforming everything into ints or tuples of ints and then frozen sets of such tuples. At the moment, it seems that all int, tuple, int, and frozen set, tuple, int, yield consistent hashes, but, is that guaranteed, and if so, how long can I expect this to be the case? Additional question, more generally, what would be a good way to write a consistent hash replacement for hash, frozen set, sum_dict.items, when the dict contains various types and classes? I can implement a custom _hash_, consistent one, for the classes I own, but I cannot override str's hash for example. One thing I came up with is
Short answer to broad question: there are no explicit guarantees made about hashing stability aside from the overall guarantee that x equals y requires that hash x equals hash y. There is an implication that x and y are both defined in the same run of the program. You can't perform x equals y where one of them doesn't exist in that program obviously, so no guarantees are needed about the hash across runs. Longer answers to specific questions. Is your belief that int, float, tuple, x, frozen set, x, for x with consistent hash have consistent hashes across separate runs, always true and guaranteed? It's true of numeric types, with the mechanism being officially documented, but the mechanism is only guaranteed for a particular interpreter for a particular build. sys.hash_info provides the various constants, and they'll be consistent on that interpreter, but on a different interpreter, Python versus PyPy, 64-bit build versus 32-bit build, even 3.n versus 3.n+1, they can differ, documented to differ in the case of 64 versus 32-bit Python, so the hashes won't be portable across machines with different interpreters. No guarantees on algorithm are made for tuple and frozen set. They can't think of any reason they'd change it between runs. If the underlying types are seeded, the tuple and frozen set benefit from it without needing any changes, but they can and do change the implementation between releases of Python, e.g. in late 2018 they made a change to reduce the number of hash collisions in short tuples of ints and floats. So if you store off the hashes of tuples from say 3.7 and then compute hashes of the same tuples in 3.8 plus, they won't match, even though they'd match between runs on 3.7 or between runs on 3.8. If so, is that expected to stay that way? Expected to, yes. Guaranteed, no. I could easily see seeded hashes for ints, and by extension, for all numeric types to preserve the numeric hash/equality guarantees, for the same reason they seeded hashes for str/bytes, etc. The main hurdles would be: it would almost certainly be slower than the current, very simple algorithm. By documenting the numeric hashing algorithm explicitly, they'd need a long period of duplication before they could change it. It's not strictly necessary. If web apps need seeded hashes for DOS protection, they can always just convert ints to str before using them as keys. Is the Python hash seed only applied to sort the hash of strings and byte arrays? Beyond str and bytes, it applies to a number of random things that implement their own hashing in terms of the hash of str or bytes, often because they are already naturally convertible to raw bytes and are commonly used as keys in dicts populated by web-facing frontends. The ones I know of offhand include the various classes of the datetime module, datetime, datetime, though this isn't actually documented in the module itself, and read-only memory views of with byte-sized formats, which hash equivalently to hashing the result of the views.toBites method. What would be a good way to write a consistent hash replacement for hash frozen set sum_dict.items when the dict contains various types and classes? The simplest/most composable solution would probably be to define your const_hash as a single dispatch function, using it the same way you do hash itself. This avoids having one single function defined in a single place that must handle all types. You can have the const_hash default implementation, which just relies on hash for those things with non-consistent hashes, in a central location, and provide additional definitions for the built-in types you know aren't consistent, or which might contain inconsistent stuff there, while still allowing people to extend the set of things it covers seamlessly by registering their own single dispatch functions by importing your const_hash and decorating the implementation for their type with that const_hash.register. It's not significantly different in effect from your proposed const_hash, but it's a lot more manageable.
If you want to support the channel, please consider liking and subscribing.